that you may have just taken. And with this quiz, there's probably two things that you should be aware of. The rules that you see right over here that I've highlighted and the periodic table and how to use the periodic table. If you know how to use the periodic table and find some information on it and apply these three rules over here, you should have no problem with the chart. But if you're watching this video, you might have had some struggles with it. So the main thing I want to kind of get at is to realize that there's enough information in each row that you can fill in the missing information. It's just a matter of knowing how to read the periodic table or applying those rules that are over there as well. So for instance, if we just jump into the first one, you might notice over here that we're starting with carbon. So carbon is the substance that we have. And if we look at the periodic table and we search around, the more you're familiar with the periodic table, the easier this will get. But if we search around, you'll find carbon on the periodic table. So it tells us a couple things, at least this periodic table tells us a couple things. It tells us the symbol we use to represent carbon, and it gives us this number right here, that's 6. That 6 is the atomic number. So what you can do then at this point is say, hey, let's put the symbol for carbon right here, and then the atomic number is 6. So just from the periodic table, we can find out a bit of information on what substance we're dealing with, carbon, the symbol for it, and the atomic number. So those three things are linked together based on the periodic table. So that means that you can pretty much follow these three columns by using the periodic table and just using one of those things to help out with that. All right, so the next thing that we can get into is talking about like the fact that right by the carbon there's no number right there, so that means it doesn't have a charge. Just like this carbon right below it, it doesn't have a charge either. We'll get into the charge in just a second because we probably want to add that to our symbol as well. But as we continue along, let's take a look at what else we can do with this table. So this table, again, can be filled out by using these rules. And so I want to look down at the rule. I call it the blue rule in this case. It's the atomic number is equal to the number of protons. So going back to our table, if you think about the atomic number is equal to the number of protons, what that means is that this number right here, the 6 in that case, is going to be the same as that number. So we would just say that those would be the same. So we could go all the way down the line here, and whatever we have in one column, we'll put it in the other column. So this number right there will be a 6. Okay, and if we know this number and that number, that means we can fill in those two as well. Okay, so that rule right there allows us to link together the number of protons with the atomic number. Okay, we still have more information to fill in though on this table, and so I want to now take a look at the third rule down below there. That's the red rule. It says that charge is equal to the number of protons, subtract from that number the number of electrons. So if we look at our number of protons, and we're going to go back to carbon here, if we look at our number of protons, which is right there, what we're going to do is we're going to subtract the number of electrons from that number. So 6 take away 6 is equal to 0, and that's why the symbol then would have a 0 right there for its charge. However, a lot of times we don't write a 0, we just leave it blank just with the assumption if it's just by itself, that letter C by itself, that means there's no charge. If it did have a charge, then what we would do is we would write it like we do down here with the K with the plus and the O with the 2 negative. Okay, we'll get to those in just a moment. Okay, now our next part then is to start looking into the number of neutrons. So we have to figure out how many neutrons we have in that carbon. So this clue on that one is to go back down to these rules and look at the yellow rule. And the yellow rule basically states that the mass number is equal to the number of protons plus the number of neutrons. So we're going to go back up here and we're going to say, all right, well, the mass number, and that would be this number right here, is equal to the protons plus the neutrons. So what we got to do is we got to take the number of protons and we're going to add the number of neutrons to it, and then that's going to give us our mass number. The problem in this situation is we don't know the neutrons or mass number, so it's impossible to solve that problem. But there's another clue, and the clue is right over here within the name. There's a missing E right there, by the way, but within the name, this number that's attached to the name basically makes that an isotope, and that's the mass number that we put on the name right there. So this carbon, this specific carbon we're talking about, has a mass number of 12. So now we can plug in the number 12 right here. And that allows us then to determine the number of neutrons. So according to our rule, the mass number is equal to protons plus neutrons. So that's the neutrons right there, will equal 12 in this case. So I will put a number 6 right there. So that's the number of neutrons. So those are the steps to go through solving that first little, that row right up there. And so now at this point, we should be able to continue on applying those rules to the rest of this. So if we go to the next row, row number 2, we're still dealing with carbon. So if you look right here, it's carbon that we have. And so looking at the periodic table, we know the atomic number is 6. And since we have atomic number of 6, that's going to equal the number of protons, the blue rule right below. And then now what we can do is start thinking about, well, what about the mass number? Maybe the mass number will help us. And so according to the red rule, okay, or excuse me, the yellow rule that's below, and I say the yellow rule is in the mass number is equal to protons plus neutrons. So we can say that we're going to take the number of protons, we're going to add the number of neutrons to it, and it should equal 14. So if we can do our math, then you're probably all right with knowing that that would be a number 8 right there. My 8 doesn't look very good. I'll rewrite that real quick for us. So that's 8 for the number of neutrons. Now let's go back to the charge rule. The charge is saying that protons minus electrons will equal the charge. In this case, the charge is written right here on the symbol. There is no number right there, so we just assume that it's a charge of 0. And that means then that if we're going to take our protons and subtract our electrons from it, we should get 0. Okay, so that means then to do the math is 6. Take away 6 will equal our charge of 0 right over here. That's supposed to be an arrow pointing at that 0. Okay, so now we have all of that information. The last bit is to fill in the name. Well, the name is whatever the C stands for on the periodic table. Again, the C right up there is carbon. So I'm going to write carbon. And then in this case, I'm going to put the mass number behind it, and the mass number is 14. So this is the isotope called carbon-14. And the only difference between that and carbon-12 is that it has 2 extra neutrons in its nucleus. All right, we're going to keep moving on then. So let's go to this third one. This third one looks a little bit suspicious because we can't figure out what these are right here. But if we know the atomic number, we have to go back to the periodic table. So you go back to the periodic table, you find which one has atomic number of 3. And I can't get my icon to move right up here, but if I were to search over farther to the left, I'd find that the element that has atomic number of 3 is lithium. So then that's the name of it. And then we're going to put the mass number attached to the lithium. So to find the mass number, you might remember, okay, we want to look down over here to our rules. The mass number is equal to the protons plus the neutrons. So I just need to take these two numbers right there that I highlighted, add those together, and that will give me my mass number of 7. Now remember, you can take that mass number and you apply it to the back end of that name. So I'm over at that lithium name right there, and I'm writing the number 7 right there. Okay, and then lithium has a symbol of Li. And now we have to decide, does it have a charge? Does lithium have a charge? Well, the charge is equal to the protons minus electrons. So I'm going to clean this up a little bit over here and say, okay, so protons, which is 3, take away electrons, which is 3. So 3, take away 3 is 0, so it does not have a charge. So that means I'm safe just to leave lithium as it is right there. So that's supposed to be an I. I could write the 0 right there just to show that it has no charge, but a lot of times in chemistry we don't write those zeros up there unless it's important that we do that. Okay, our last two then have charges on them. So that one, that potassium right there has a plus charge, and the oxygen has a -2 charge. So we got to figure out what that applies. So let's kind of go into this deal. So if we take a look at potassium on the periodic table, I find it right here. Remember that allows me to figure out the atomic number. So I'm going to look at potassium's atomic number, and I'm finding 19 for its atomic number. So I'm going to write the number 19. And remember the blue rule that's right below there says that the atomic number is equal to the number of protons. They're always the same. So I'm going to write that next over here. So those two numbers are going to be the same. And while I'm at it, I'm going to look at oxygen real quick. You can actually see it on my periodic table right above here. Oxygen has an atomic number of 8, so I'm going to write 8 right there. And that means, according to the blue rule, or the atomic number rule, it's 8 protons as well. Now we have to figure out neutrons and electrons, so let's jump into the mass number rule right over here, the yellow rule. So the mass number rule tells us that the number of protons plus the number of neutrons is equal to the mass number. So what we got to do in this case is we're going to look at the mass number, and it's right here, 39, and we're going to take 19 and whatever the number is for neutrons, we're going to add them together. So I'm going to put a little question mark right there. So 19 plus something is going to equal 39. Just like the one right below it, 8 plus something is going to equal 16. Okay, so we're doing the same kind of process for both of those questions right there. Okay, so if we take 19, and whatever we add to 19 has got to equal 39, or you could do 39, take away 19 if you're good with your math. And so in this case, that would be 20 for the neutrons, and then for the oxygen, it would be 8 neutrons there. All right, now we're going to take it to the part that a lot of people struggle with this part, and that's applying the charge and figuring out how that equates. So if I could write this out, this might help us out too as well. So the charge is equal to the protons minus the electrons. So in that first case, our charge of potassium right over here, if we look at the very top, right where I'm trying to point with that arrow, it has a charge of plus, and that means plus 1. So it's a positive 1 charge. And that charge is equal to the number of protons. So I'm going to write in the number of protons that's coming from right there in that equation. And I'm going to subtract the number of electrons. So I need to subtract an unknown number right now because we don't know how many electrons we have right there. So 19 minus something is going to give us a positive 1. So if I take 19 and I take away 18 from it, that will give me a positive 1. So I'm going to erase some things here just so I can fit it in. This would be 18, okay, right there. And so according to the math then, that's how we solve for that positive 1. Okay, the next one I want to look at is our oxygen. So oxygen has a charge of 2 negative. So our charge, according to the red equation down below there, is 2 negative, or negative 2. It's kind of, we write that backwards in chemistry. There's a reason for it. We don't need to get into that now, but that negative goes behind the 2. So it's negative 2. And we're going to have the number of protons. So in oxygen's case, it has 8. And we have to subtract a certain number to get negative 2. So if you're good with your math, you might be able to do this in your head. But basically, whatever we have here in that question mark, it has to be bigger than 10 to get to that negative range in that negative 2. So the number that would be 10. So if 8 minus 10 is equal to negative 2. So our electrons for oxygen in this case would be 10. So that's how you fill this out. Remember what I said at the beginning, know how to use the periodic table. The periodic table helps you with this part of the chart right there. And then those rules, the 3 rules over here, helps you with the rest of the chart over on that right-hand side. I hope this was helpful, and I hope you watched it all the way through. And good luck if you get a chance to do a retake.